Hello. Yeah, I want to take a few minutes just to uh, walk through one problem from chapter 9, and that is on valuation. And we have this question 8, and let's see how we can go about in trying to work through this problem. And this is a bond problem. So, assuming you are a financial analyst and you want to find the price of a bond. The bond has a par value of $1,000 and its quoted annual interest is 12%. Again, this is 12% per year, which is paid on a semi-annual basis. The yield to maturity on the bond is 14%. And that's an annual interest, and there are 20 years to maturity. And you're given two tables, Appendix B and Appendix D, for an approximate answer, but you're required also to use a financial formula or a financial calculator to determine the value of the bond. So in part A, we are being asked to determine the price of the bond, that is the value of the bond. Again, this is a valuation problem based on a semi-annual analysis. So again, think about it. I said this before. Anytime we are talking about a bond, then what we are referring to is a financial instrument that promises to pay you interest, and then at maturity it pays back the face value of the bond. So in order for us to identify or even compute the value of this bond or the price of this bond, it is important we identify the variables that we need. So let me just draw a timeline here just to give us some kind of perspective. So we are talking about a bond here. And if I just draw an example here, in this example, this is a bond for 20 years. So the bond is going to mature in 20 years. And at maturity, we know the bond has to pay back the face value. But this bond is also promising some interest payment. And again, I said, to compute the interest payment, what we need to do is to use the stated interest rate, the coupon rate, the nominal rate to determine the interest payment. Now, in this example, our interest payment is 12%, which is quoted on an annual basis. However, the interest payments here are being paid every 6 months. So every 6 months here, you pay an interest. At the end of the year, you pay another interest, and then again, in the next 6 months, you pay an interest. You pay the second year, all along until 20 years. So in terms of the total periods, let's identify the total periods. So the total periods in this example, if you're going to use the table or even the financial calculator, the total periods are going to be the number of periods per year, which in this case we're talking about paying an interest every 6 months. So in a year, you have two periods in a year. And we are talking about this bond maturing for 20 years. So given that, then the total periods are 40 periods. So your N will be 40. And your interest per period, your interest per period is going to be what the yearly rate that is quoted. In this example is 12%, but then you are paying this interest per period. And how many periods do we have in a year? Again, we have two periods, and therefore your interest per period is going to be 6%. Then we can now identify how much that interest payment is every 6 months. So we just have to use our rate per period here, which is 6% of the face value of the bond. The bond is being sold for $1,000. Oh, no, the bond has a face value of $1,000. Sorry, has a face value of $1,000, and therefore our interest here is going to be, you take the $1,000 times your rate per period, which in this case is 6%. And you do this bond is paying you $60 every 6 months. So every 6 months, you have 60, you have 60, you have 60, all along again until the 20th year. Now, you could also just use 12% as your rate, and 12% of 1,000 will be 120. But then you have to remember we are paying interest every 6 months. Then you will divide 120 divided by 2, and then you still have the 60. So you could either go either way, but the most important thing is to make sure you identify the correct payment in terms of interest. Again, we use the stated rate or the nominal rate or the coupon rate to determine the interest payment. In this example, our quoted rate, our coupon rate, our uh, nominal rate is 12% per year and therefore 6% per period. This gives us $60. Now, so what we need to do is, in order for us to determine the present value or the value of this bond, again, we said the value of any project or any financial instrument is basically going to be the present value of the cash flows. The present value of the cash flows for this bond is the $60 every 6 months. In addition to that, the bond will pay you the face value at maturity, which is $1,000. And therefore, you could determine the value of this bond by either, again, you could use the tables you've been given, or you could use the financial calculator, or you could use Excel, or the formula as you might deem fit. In this example, I'm going to just to use the uh, Excel to compute the present value. So I will go to the Excel, and then what I'm going to do, I'm just going to pull up, we are looking for the present value, and that is the price of this bond today at time zero. So what we're doing is we're basically discounting all these payments back to present plus the $1,000 back to present, and then we add all of them together, and that will give us the value of this bond. So if I go to Excel, what I'll do is to determine the present value, so just be the present value of this bond, I know that the rate, again, to discount those payments, you have to use the market rate or the yield to maturity or the yield rate. You're using the market rate to discount the cash flows, but we use the coupon rate, the stated rate, to determine the amount of the interest payment. So in this case, because we are discounting all the cash flows, we are going to use the market rate. In this example, our market rate is given to us. In this example, our market rate, if you remember, we're being told the yield to maturity is 14 per year. But remember, this is per year. But for this bond, it is paying interest every 6 months. And therefore, our rate per we need to determine the rate per period or the market rate or the yield rate per period. In this example, again, you will take 14% divided by 2 periods per year, and therefore your rate is going to be 7%. And therefore, we are going to discount this bond using 7%. So you'll have 7% as your yield to maturity, and that is per period. And then the amount of payment is those $60 every period. So you have $60. Uh, no, I mean, no. First of all, we need to determine the number of periods. How many periods do we have here? We said we have 20 years and we have 2 periods per year. So we have a total of 40 periods. And then in terms of the payment, it's $60 every year. And therefore, our cash outflow is $60 every period. And then the future value is basically the face value of this bond. Remember, when this bond matures, it has to pay the face value. And the face value of this bond is $1,000. So again, that would be our future value. Again, we're assuming these payments are at the end of the period, and therefore our type here will just be zero. If they're coming at the beginning, you'll say you'll indicate one or use one. But in this case, we're going to assume, again, remember, it's zero at the end of the period and it's one if it's at the beginning of the period. So in this example, by default is at the end of the period. So you basically even ignore and don't even insert zero there. Otherwise, if you insert zero, that doesn't make no difference. And that will give us the present value of this bond. So the present value of this bond is 866 and 68 cents. There's also another way to look at it. So another way to look at it, again, just using Excel, what you'll do is you'll determine the present value of the annuity payments, which is basically the $60 each period here. And then you can also determine the the present value of the first value at the end of the uh, uh, at maturity. So what you'll do is, again, you determine the present value of the annuity payments. Again, we know this. You basically again do, just to prove that 866 is the correct value, you have the present value of the annuity payments. Again, our rate here is 0.07, it's 7%. And the number of periods for us here, again, there are 40 periods. And our payment is $60 every period, and our type here again is at the end. Again, you just put zero or you can ignore, and therefore the present value of only the $60 only then is going to be 799 and 90. Remember, this is the present value of annuity payments, which is in this case is the $60 that you're seeing. And then to determine, then we need to also determine the present value of the single amount to be received in the future, which is the first value of the bond. And therefore, the the first value of the bond, the present value of the $1,000 will be, again, you could do the, again, the rate here is 0.07, and our number of periods again here it's 40, and the payment again we're going to assume is zero because we've done the annuity in the first case. So here we assume there's no payment. You basically saying what's the value of the $1,000 that you're going to receive, 40, 20 years from today. And therefore the future value is 1,000. Again, we're assuming this is at the end of the period. By doing so, this will give us uh, the present value of that $1,000. Then what you do is determine the value of this bond. You'll basically just sum the two. Uh, you just have to sum the two values, and that's the present value of the annuity and the present value of the first value. And you do that, and again, that will give you the same thing, which is, again, you could see the 866 and 860. So there's so many ways you can do and work through the problem to give you the same answer. The other alternative, of course, is to use the financial tables or the calculator to determine the same thing. But that gives you a sense of what we're saying and how we determine, of course, the value. So the value of this bond again is going to be the 866.68. So it'll be 866. The 866.68 will be the value of this bond today, given those terms. The terms are on a semi-annual basis at 12% being the quoted rate. That's the stated rate, and 14% being uh, the market rate, or the yield rate, or the yield to maturity. With the second problem, again, we are being told. With the second problem, you're told that with 15 years to maturity, if the yield to maturity goes down substantially to 10%, what will be the new price of the bonds? Again, in this example, again, the same thing. So if I draw here my time value line, and again, I have 1 year, 2 years, 3 years, and continue all the way to the 15 years that I referred to here. We know that this is still on a semi monthly basis, because it's the same example, but just a subset of it. So every 6 months it's paying interest, every 6 months, 6 months, 6 months, and so on until 15 years, because we only have 15 years left. So in this example, then our N is going to be the 2 periods per year times the 15 years that are left. Again, our N is going to be 30. That's the total number of periods. And in terms of the our market rate, or the yield to maturity, again per period, this example will be what is given to us as the yield to maturity, which is 10%. And again, divide this by 2, because we have 2 periods per year, and therefore you are talking about 5% uh, being the yield to maturity per period. Again, then you just have to use those terms. In terms of the payment, again, nothing changes, because what we're being told here is that with the 15 years to maturity, the market rate changes, but of course, in terms of payment, it will still be the same payment as in Part A. So you're still paying out $16, $60, but we only have 15 years left on this particular bond. So then in that case, what is the value of the bond? Again, if you use your Excel, you'll come in again, do the same thing to determine your present value, or the price of this bond. You'll again, your rate again goes down to uh, we're told our rate went down to 10%, that's per year, and therefore per period is going to be 5%. And then the number of periods, we have 2 periods per year, 15 years left, we have a total of 30 periods on this bond. In terms of payment, it'll still be $60, nothing changes. And then, of course, the future value of this bond will still be the $1,000. That's the first value of the bond. And again, this is at the end of the period. Given that this bond again will be going for, or will be selling for, 1,153 and 72 cents. Again, you could see with the change in interest rates. Again, this basically tells you if the market rate goes down, the yield rate goes down, the price of the bond goes up. So if the yield to maturity goes down, if the yield to maturity goes down, the value of the bond will go up, and vice versa. So again, I hope this information helps, and let me know if you have any questions. But again, the key idea to determine the value of the bond is to make sure you identify the yield to maturity per period, identify the total number of periods, and identify the amount of the interest rate. Again, if I was you, I would use the quoted rate per period and not per year. So you'll have to either divide that by 2 if it's a semi-monthly basis. If it was on a quarterly basis, Then again, you do this by 3 and so on. So let me know if you have any questions, but I hope this information helps. Thank you.